In this video we're going to be going over testing, specifically testing of software design, so Python, your programming stuff, and just having a look at kind of the theory that's going to pop up in the exam that you could be asked about. So we're going to look at the different types of test data from National 5 first, and then we're going to look at the types of errors and the two different types of testing, as well as the two different types of debuggers and a couple other debugging techniques. So let's begin with the National 5 stuff. So at National 5 level, you should remember, hopefully you remember, the different types of test data, and that is normal, extreme and exceptional. Now normal is when your test data is inside a set of boundaries. Extreme is when you're on those boundaries, and exceptional is when you're out with them. I always get a bit mixed up between extreme and exceptional, because in my head extreme sounds like more, but you're pushing something to the extreme, whereas if you're exceptional, if something is exceptional, it's going above and beyond, it's going beyond its limits. In this case it's kind of bad, but that's kind of where the phrase comes from. So say we have a program that takes a number between 1 and 10, so it's just a question that says please type in a number between 1 and 10, a little program. Any normal data would be any number between 1 and 10. An extreme test would be 1 and 10, so like I said, on the boundaries, that's the lowest and the highest value you've got. Exceptional would be anything outside that, and I mean anything. So the number 0, the number 11, they're just outside but they're still exceptional. A number 5,000, the number 5 million, doesn't matter how large the number, or low, because negative numbers would be exceptional tests as well, or even just a word, even just nothing is an exceptional test, just like a set of quotes like nothing, that could be considered an exceptional test. So that's the National 5 stuff. Oh, and remember, it's the fourth stage of the development process, of course. But why do we do testing? We do testing to check if something is fit for purpose, if it's robust, and to make sure it's reliable. Now, I've put this here because it's a common coursework question, and it'll say, is your coursework fit for purpose? So does it meet the specification? If it does work, like if you think you've got everything 100% working, just say that, but you have to be specific. You have to say it does this, it does this, it does that. You can't just say everything works. You won't get a mark for that, but you do get 1 mark for just regurgitating and just saying everything that you've already done. Robust is how it deals with invalid data. So I was talking about just a few seconds ago, if you typed in a number, if you typed in nothing, that would be invalid data. How robust is your program? Does it crash? Probably it does if you type in nothing, but yeah, I guess invalid data would also be a word. Does it crash if you put in a word, for example? So you can talk about that there. Reliable, does it consistently do its job correctly? Now this is a bit of a weird one, for the programs we're doing, if you've got everything working, it's probably reliable. It's not really likely to crash, but think about if you've got a buggy video game, I don't know, Cyberpunk, right? It's terrible, it's not reliable, crashes every 2 seconds. You couldn't say that Cyberpunk is reliable, and that's what you've got to talk about there. Here's the two types of testing. So there's exhaustive and comprehensive. Now exhaustive sees you test every single possible combination, like every possible value, sorry. And I mean, so say you have a program that takes a number between 1 and 1,000,000, you would have to sit there and manually type in the numbers 1 to 1,000,000, all the way up to 1,000,000 times. That's not very realistic. You don't want to be the person testing your program 1,000,000 times. This is more like a theoretical thing. That's the idea behind it. Very few companies in real life would use exhaustive testing, whereas comprehensive testing is using a wide range of test data. Really what we're looking at here, using normal, extreme and exceptional values. So this type of data. If you've got a program that takes a number between 1 and 1,000,000, right, and you've tested the numbers 10,000 and then 11,000, 10,500 in between is probably going to work. So there's not really a need to test that number as well. So comprehensive is the one that we lean towards. This is good in theory, I guess, if you were paranoid and wanted to really make sure, but realistically it's not possible. So the benefit of this is just that it's quicker, it's actually realistic, if you were asked about that. Test tables, you might have to fill in a test table in a coursework or an exam. This type of test table is probably more coursework related, but in a test table for like a proper program, you would have what you expect to happen. So if you were a programmer, like as your job, you would write a test table of what you expect to happen, and then near each test you would write down what actually happens, and you might add a comment on each test as well, and it could just be as expected, because a lot of the time it will be as expected. So here's an example here. Again, it's coming under normal, extreme and exceptional. It's a program that asks a user to enter their pass mark. A pass is 12 or more. So any of the numbers, if you type in 2 or 7, you expect it to say fail, and if your program's right, it will say fail, and you write as expected. Now, if it came up true, you would write true there, you'd write fail here, true here, and then here you would write not as expected, need to revisit code or whatever. And then here, like the weird values, it's saying that the program is crashing. Not really sure why a program would crash with the number 21. I just stole this table from somewhere else, but this bit, it might crash it. In Python, actually, I think Python would power on, but you get the idea. If it did crash, you would just say program crashes. What would probably be a better thing to write here is, again, like the word banana. That would crash it. That would just break your program, probably. That's more realistic. Types of error. I feel like this is almost guaranteed to come up in your exam, and there's always this one question. It's only worth a mark, but again, it's only one slide to remember. Now, I've numbered these for a reason, right? And it's because if I was running through it, if I had an exam and it said what type of error is this, I'd go through it in this order in my head. I would check if it's this, and I would check if it's that. If not, I would check if it's this lastly. And if it's not these two, it's probably this one. So syntax errors are when you make a grammatical mistake in your program. So things like you miss out a bracket, you miss out a colon, your indenting's weird, you've made a spelling mistake. That's probably the most common one. Everyone's like, my code, it's perfect, and then there'll be like one word that just has a missing letter. That's all it takes, but that's a syntax error. Because syntax is a word we use to talk about language, and well, it's a spelling mistake. So yeah, that's syntax errors. Logic is, so if it's not a spelling mistake, if all your code runs, right, but then maybe even produces the answer, it produces a answer, but it's not the answer you expect. Now that is considered a logic error. So it just means that your code is correct, like your code runs, but what you've written doesn't do what you want it to do. So easiest way to think about this, say you had a program, right, that had to times two numbers together, and for some reason you were having a really bad day and you did the divide sign instead. That would be a logic error, because you just goofed up, you just wrote the wrong symbol, and so your code is right, but instead your logic of the code is wrong. That's the simplest way to think about that, but there can be more complicated versions, of course, like passing the wrong data into a function. A lot of the time, I think you might be able to relate to this. I see some people that they return data into the main program, and then they swap the variable names around when they return them, and then that causes a logic error further down the chain, further down the program, and it causes more problems. The last one is a weird one, execution error, and it's quite hard to to detect. So hence why I say look if it's a syntax first, look if it's a logic next. But these are things that when like the program, everything's spelled 100% correct. You've wrote almost the perfect program, but then you do there's something that it just can't do. So I said divide by 0 here, so if some reason there's like, I don't know, you have to divide numbers in a file, but one of the numbers in the file is a 0, then that's going to be an execution error. It gets to that 0, it doesn't know how to divide by 0. Or more accurately, or more likely should I say, it reads from like a non-existent file. So maybe there's a spelling mistake in the file name. You could argue that's a syntax error, but or say like it tries to read from a file that, so we've been using REPL, say it's not on the little sidebar of REPL, that's an execution error, because it can't find a non-existent file. So yeah, so that's the 3 types of error. On to debugging techniques and tools. Now this is still about testing. There are 4 debugging techniques and tools to be aware of. First one is a dry run. That's when you would print out a bit of code and you kind of just like write it like step by step through something. We've kind of done that with the tracks booklets when we were doing it first. We were stepping through it and then we were seeing if the values match up. This would be it's when you're stuck in a program so much, you're looking at the screen and you can't figure out what the error is. The idea is if you print it out and then you just read and write on the bit of paper, it just gives you like a different context for like your brain to process and then try and figure out what the issue is. So that's what a dry run is. A trace table, this is like the tracks booklet where you write the values there. Now so the tracks booklet is kind of like both of these, to be honest, because a trace table could be done on a computer, but we did it on paper, so we kind of combined this and the table together. But a regular trace table is just, I guess, if it was on the computer and then you were just following the values through that. But well, you can do it practical as well. These next 2 bits are a bit weird, right? We don't use them in class. I don't like them. I find them very difficult to use, but you need to know the theory behind it. The question, you'll probably be asked about one of these, to be honest. So breakpoints is something that you set and it will stop the code at a certain line, right? So you set it at line 12 and then the program will run to line 12 and then it will stop and it lets you see the variables. Now that sounds very handy. It is, but I think it's quite overwhelming, if I'm being honest, especially when you're learning programming. I think it's very overwhelming. I find it overwhelming. I think this is a lot of information thrown your way. So I tend to just use print statements. I've stolen this from another PowerPoint, right? And that's because the REPL doesn't, well, it does have breakpoints, it just looks a bit different. But the idea is if you were to follow line 34 here, you can like step manually through every line and it will show you how values are changing. I like to just write print statements everywhere instead. But the REPL version I don't really like it that much. Maybe I'm doing something wrong. I just don't like it. So say I wanted to put it on line 6 here. Here's a find minimum program, and I was to go, you just write breakpoint, and then what it does is it gets to this line, and then it stops. It just tells you the code, and then if you press the H button, it gives you a help screen like this. There's a lot. I think the ones you want to use is step, and it lets you step through the code a line at a time, but it's just showing me the code. I really don't like this. I don't see a benefit in this right now. Maybe I haven't just played about with it much, but there's a bunch of crazy things, as you can see. I just don't like it. What I would do if I wanted to know what happened at this point, I would just go print minimum, right? But despite my distaste to it, you need to know what it is, what a breakpoint is. So the idea is it stops at a certain line, and then it lets you look at every value, every variable up until that point. Okay, a watch point is similar, but the difference is you are following one particular variable throughout the whole program. So you'd watch as it changes. So in the previous example, it would be like if you watched minimum and you watched how minimum changed constantly throughout the program, it would give you a list. I'm not going to demonstrate it because I don't think REPL can do it. I've tried really hard to get it to work, and there's not like an easy way. You can't just write watch point or whatever, as far as I'm aware. So yeah, instead I've stolen this, and so here it's got a little program where as soon as this value counter equals 1, the program will stop. So you'll track the value of counter until it reaches that, and then the program, and it'll show you how counters changed over time until it gets to that value. So it'll show you it starting at 0, and then as soon as it gets to 1, or if you made this 10 instead, it would show you it get to 1, then 2, and it would tell you when and where. So this is about specific lines, and this is about specific variables. So I made this because they are quite confusing. So you assign this to single lines of code, and you assign this to variables. This stops when you reach that line. This stops when you reach a value. This shows every variable up to that line. Well, this one just shows you that one variable you attach the watch point to. Last slide is to combine techniques. I'm putting this up here because I noticed there was a past paper exam question that was, I can't remember what year it was, and you had to combine, you had to talk about how each of them brings, what each technique brings to the table. So I kind of talked about it before when I said, where is it? When I said trace tables, so it's like a physical, it's like a table that you write all your values out and work through, and a dry run is you doing that on paper. That's kind of what we did with the tracks booklets. So you would talk, if you were to talk about that, you could say dry runs can be used to help fill in the values of a trace table. So you do them on paper or and you're just talking about the advantage of them both being combined. Breakpoints can be used with trace tables to make sure the values match up. So if you've got a trace table and it shows you a variable changing over time, you could use a breakpoint to make sure that variable is changing over time how you expect it to. So yeah, this is just like just be aware you might be asked to explain how they can be used together. That is everything from me. Right, thank you for watching. Bye.